Write this number in expanded form using fractions and using exponents. Expanded form recognizes the place value of the digits in the number. So 3 is in the units or ones place, 7 is in the hundredths place, and 6 is in the millionths place. So using fractions, we can write 3 plus 7 hundredths plus 6 millionths. Using exponents, we're going to write powers of 10 using negative exponents rather than using fractions. So we have 3 plus 7 times 10 to the negative 2 power plus 6 times 10 to the negative 6 power. Write each number in scientific notation. So to be in scientific notation, we need to have one non-zero digit in front of the decimal point, and then we're multiplying by a power of 10 so that we have a number equivalent to the one we started with. Remember, if you have a large number, the exponent on your power of 10 will be positive, and for a small number, a small decimal number, the exponent on your power of 10 will be negative. Order these numbers from least to greatest. So think about the place value of the numbers, and when you have a repeating decimal, you have fractions that continue forever. So if we take each of these numbers and we consider the value of the digits, we can start to compare using the numbers that have the same place value. So all four numbers have a 3 in the ones place, and all of them have 6/10ths. But when we start to compare the hundredths, we can see that the first two numbers have fewer hundredths than the last two numbers. So they would have to be the first two numbers. Now to figure out which one of those numbers is the very smallest, we have to go to the thousandths place, and we can see that the second number has fewer thousandths than the first number. The last two numbers have to be our largest numbers in this case, and the very last number would be smaller than the 3.6 repeating because it does not have any thousandths, but the 3.6 repeating has 6 thousandths. So in order from least to greatest, we have the numbers in this order. Write this number as a repeating decimal without using bar notation. The first three digits don't repeat, but after that we need to keep repeating 997 over and over again. So we'll have a number that looks like this. Write each of these fractions as a decimal number. Seven 25ths is the same thing as 28 hundredths. Now you can take 7 and divide it by 25 to get that number, or you could rewrite 7 25ths as the equivalent fraction 28 over 100 by multiplying numerator and denominator by 4, and that would lead you to the decimal number 0.28. For 25 24ths, you can divide 25 by 24 and get a repeating decimal, 1.0416 repeating. Write each decimal number as a fraction in simplest terms. For the first one, since it's a terminating decimal, we could say 54 hundredths and write 54 hundredths, and then simplify the fraction to get 27 50ths. The second decimal number is a repeating decimal. So we'll say that x equals that repeating decimal. And since there's one repeating digit, we'll multiply both sides of this equation by one factor of 10. If we subtract on both sides, we'll be subtracting off all those repeating 6's. And we can divide both sides by 9, which does give us something that looks like a fraction, but it's not in the right form because there's a decimal on the top of the fraction. So if we multiply numerator and denominator of 24.9 over 9 by 10, we'll have 249/90ths, and dividing numerator and denominator by 3 gives us 83/30ths. Without dividing, explain whether each of these fractions can be written as a repeating decimal or as a terminating decimal. In either case, we have to make sure the fraction is simplified before we make a decision about whether it repeats or terminates. And both of these fractions can be simplified. Then we look at the denominator of the simplified fraction, and we look for the prime factors of the denominator. In the case of 4/5, the prime factor of the denominator is 5, and as long as the denominator's prime factors are only 2 or 5, or any combination of 2 or 5, we have a terminating decimal. On the other hand, when we look at the denominator of 1/6, it has prime factors of 2 and 3. So, since 6 has a factor of 3, we can say that 1/6 must be a repeating decimal. The denominator has a prime factor that's something other than a 2 or a 5. 1/6 has a denominator with a prime factor of 3 in it. Perform the indicated operations. Remember, you cannot use a calculator for these. Check your answers, see if you're right. Why must decimal points be aligned when adding or subtracting decimal numbers? Well, the explanation has to do with place value. If we align the decimal points in the numbers we're adding or subtracting, that assures that the digits with the same place value are going to be added. If you think about this as an example, if we try to add 3 2/10 and 4 21/100, we're really looking at numbers that have a whole number part and tenths, and in the case of the second number, 100th as well. Now when we're adding fractions, we know we can only add fractions with like denominators. So to make sure that we're adding the tenths in the first number to the tenths in the second number, we're going to have to align the decimals so that we are adding fractions with the same denominator. In other words, we're adding decimals that have the same place value. Write the first number as a percent and write the second number as a decimal. So to change a decimal to a percent, we move our decimal point 2 places to the right. And to change a percent to a decimal, we move our decimal point 2 places to the left. If this entire square represents one whole, express the value of the shaded part of the square as a simplified fraction, as a decimal, and as a percent. The entire square is divided into 100 equal pieces, and there are 16 of them shaded. So as a simplified fraction, we can call this 16/100ths, which simplifies to 4/25. As a decimal, if we say 1600ths and write 1600ths, we have our decimal number written. And since percent means out of 100, 1600ths would be the same thing as 16%. What is 140% of 94? If you want to use the percent proportion to solve this problem, you have to realize that the 94 is the whole and we're looking for the part, which means that the part we're looking for is 131 6/10. 28.6 is 44% of what number? In this case, the unknown is the whole, and the 28 6/10 is the part. So the whole is 65. Yesterday there were 30 students absent from Crestview Middle School. Today there were 35 absent students. What is the percent of increase in absences? So the first thing we have to find is how much the absences changed. So we have 35 absences today, 30 yesterday. That means we had a net change of 5 absences. Then what we want to find is what percent of the original amount, 30, is that 5 absences. So we're looking for the percent when the part is 5 and the whole is 30, which means the percent increase in absences is 16 2/3%. Simplify each of these radical expressions. For both of them, we can look at the prime factorization of 72. You could get the prime factorization by using a factor tree to break down 72 into a product of prime numbers. In the case of the square root of 72, what we're looking for is pairs of factors that are the same. And we have a pair of 2's and a pair of 3's that are included in the number 72, which means the square root of 72 is 2 times 3 times the square root of 2, or 6 times the square root of 2. In the case of the cube root of 72, we're looking for 3 factors that are identical inside 72. And we do have 3 2's. So we can take those 3 2's and say that we're going to group them together as a single factor of 2 on the outside of the radical. The other 2 3's we have to leave inside the radical because we don't have 3 of them. So we have 2 times the cube root of 9. Order these numbers from least to greatest. We're going to use some estimating skills to figure this out. First of all, the square root of 17 has to be just a little bit bigger than 4 because the square root of 16 is 4 and 17 is bigger than 16. The cube root of 64 is the number 4. And 5 plus the square root of 3 is 5 plus something that's a little bigger than 1, because the square root of 3 has to be bigger than 1 and less than 2. After all, the square root of 4 is 2. So 5 plus the square root of 3 has to be something bigger than 6. And 5.2 is 5.2. So now when we compare these, we can see that 4 is the smallest number. Something that's a little bit bigger than 4 would be the next smallest. Something that is 5.2 would be the next smallest, and the largest number is the number that's bigger than 6. So if we put the numbers in order, this is what we have. Find the value of x. Since this is a right triangle, we can use the Pythagorean theorem to find x. Remember that the hypotenuse, that's the side opposite the right angle, represents the c in the Pythagorean theorem, a squared plus b squared equals c squared. So the value of x, the length of that third side of the triangle, is the square root of 105. If the horizontal and vertical distance between consecutive dots is 1 unit, draw a line segment with a length of the square root of 8 units. So what we need to do is find a square that has an area of 8 units. If we can do that, then the length of each side of the square will be the square root of 8. Now this square is close to what we want, but it's not quite right. The area of this square is 9 square units. So it's got an area that's a little bit bigger than what we want. Since 8 is not a perfect square, we know that the square we're looking for has to be a tilted square, and it has to be just slightly smaller than this one. So this is the square that's going to work. The total area inside the square is 8 square units, which means the length of each side of the square is the square root of 8 units. Does the data shown in each table represent a function? Why or why not? For the first table, we do have a function because every input, every x value, maps to exactly one unique output. In other words, if we look at 3 as an x, that matches up with only one value for y, which is 9. 2 maps to 7, 6 maps to 8, and 4 maps to 9. But for the second table, we do not have a function. And that's because there is a value for x. There is an input that maps to 2 different outputs, and that would be the value of x that's 3. We have a 3 for x that maps to a 9 for y, and a 3 for x that maps to an 8 for y. So those two ordered pairs are what make the second table not a function. Represent the function using an arrow diagram, a graph, function notation, and then say what the domain and range of the function are. An arrow diagram maps the numbers in the domain to the numbers in the range for the function. So the first ordered pair maps 1 to 2, the second one maps 2 to 4, and then 3 to 6, and then 4 to 8. So an arrow diagram just shows with arrows how the x and y values of these ordered pairs are related to each other. For a graph, we have to remember that the x-axis is horizontal and the y-axis is vertical. So we're graphing these 4 ordered pairs. Since they're the only 4 ordered pairs we have in the function, we do not connect them with a line. For function notation, we need to have a way to say how every x value matches up with every y value. And what we can notice in this case is that all of the y values are twice as big as their corresponding x values. So for function notation, we could say f of x equals 2x. The domain is the set of all the x coordinates of the points. And the range is a set containing all of the y coordinates of our points.